Okay, so we start. We are doing chapter 1, class 11th, unit and dimensions. And in that chapter, we studied a lot about unit and the measurement of the physical quantities. Already, I told you that physical quantities, they are categorized in two types, microscopic physical quantities and macroscopic physical quantities. So there is a need to measure the dimensions of both the two quantities. And in our today lecture, our interest is measurement of errors. Whatsoever experiment we do, whatsoever observation we do, there are chances of error. No measurement is perfectly accurate, whatsoever precise the instrument may be, and whatsoever precisely the observation is taken. So always there are chances of error in both the categories. Any observer, how precisely or how accurately he is observing any phenomena or whatever quality of the instrument we are having, in both the cases the chances of errors are there. So uncertainty of measurement is technically called as error. Uncertainty in the measurement, because it's very difficult to find out the true value in any experiment, even in any observation or in any experiment. It's very hard to find out the true value. We are in search of true value. If we are not getting the true value, it means there are error in our observation, or there are error in our instrument. So now today lecture is how the errors they can be expressed. Before this lecture, we discussed about systematic error and random error. So today our topic is method of expressing the errors. So there are four methods by which error can be expressed. So first is absolute error. Second is mean absolute error. Third is fractional error or relative error. And fourth is percentage error. So we will discuss all these four terms one by one. So before these four terms, in any observation or in any instrument or in any experiment, always we are in search of a true value. We are in search of a true value because there exists the true value of any phenomena, of any observation, of any experiment. For example, we know the true value of acceleration due to gravity is 9.8 meter per second. And we know that how much time Earth takes to revolve around the sun, how much time it takes to complete a single orbit. We know that it is 365.24 days. So it means that is a true value. That is a true value. But it's very rare that in our observation we are getting the true value. So if we are not getting the true value in our observation or in our experiment, so how to proceed, how to do the experiment, how to be sure that our results are right, how to be sure that our calculations are okay. So the method is that if we are performing any experiment, so we are getting so many values because we are repeating the experiment. If we do the experiment many times, then the chances are there that we can meet the true value, we can get the real value, we can find out the true value. So first thing, in any observation or in any experiment, do that observation many times, repeat the experiment many times, so you will get a large number of values. And if the observed value or the measured value, they are matching with each other, if they are matching with each other, suppose we are interested in finding the acceleration due to gravity. We know the true value, it is 9.8 meter per second, but in our experiment we are getting 9.7, 9.6, 9.9, and so many values. So we will take all the values which are very close to the 9.8. We will take only those values which are very close to the true value, and then we will proceed for the next step. We will proceed for the next step. So So next step is we will take the mean. All the values which are very close to the true value, we will take the mean of all those values. So all those value, when they are taken the mean of those value, so it means that will be like a true value for our observation or for our experiment. I repeat it, true value is something else, but in our observation or in our experiment. So to match the observed value or to match the measured value or the experimental value with the true value, perform the experiment, perform the observation many times, get the so many values, and choose only those values which are close to the true value, and then take the mean of all those values. So that mean that will be very close to the true value. Now we take the first type of error, which is called absolute error. So absolute error, that is the difference of the two value. First is called the true value minus measured value. So true value and minus measured value, that will give me the absolute error. So let me take one example. Again, I just repeat the same statement. We know the acceleration due to gravity is 9.8 meter per second. That is my true value. But my measured value, that is 9.7 meter per second scale. So what is the absolute error? 9.8 minus 9.7. So that will give the absolute error. True value minus measured value or observed value. So true value minus measured value, that will give. This is the formula which is used for the absolute error. I repeat it, absolute error, that is equal to true value minus measured value. True value is 9.8 meter per second square and measured value or observed value is 9.7. If it is 9.7, then we will take 9.7. But if it is 9.6, then we will take 9.6. So the difference of the true value and measured value is also called the observed value. So the difference of the two, that will give the absolute error. And absolute error is all the time taken as positive, because we are keeping the difference of true value minus measured value in these mode, into the mode, and any value that is kept into the mode, these vertical lines, they are called mode, so that is always positive. So absolute error, it is the difference of true value and measured value, and it is always positive. Second is mean absolute error. Mean absolute error. So we will take all the arithmetic means of all the absolute errors in is considered as the mean absolute error or final absolute error of the value of the physical quantity which is under observation. So take the mean of means we are getting the relative error. So we are getting, so suppose this is my first relative error in the first part of the observation, second relative error in the second part of the observation, third relative error in the third part of the observation, and then take the divide this by the total number of observation, then we will get the mean absolute error. We will understand the mean absolute error in detail with the help of certain examples. So this is the formula, summation 1 upon n, I is equal to 1 to n, 1 to alpha and delta ai. So this is the formula for mean absolute error. The mean absolute error, it is also positive because you see them, all the values, they are kept in the mode. Third is a relative error. The relative error of a measured physical quantity, it is the ratio of mean absolute error to the mean value of the quantity measured. So relative error means we will take delta A mean divided by A mean. So with the help of the example, we will go through the relative error. So by the definition, it is quite hard to understand the concept. So I have numericals. So just go through the formula. Now the percentage error, delta A mean divided by A mean multiply 100. So this is the percentage error. So let me make all these 4 errors clear with the help of this beautiful example. So that will make the things very clear. So let me take one experiment. We are doing experiment on simple pendulum. A simple pendulum means a ball is suspended with the help of a thread or with the help of a string. So that is a simple pendulum. I oscillate my simple pendulum, and I note the time period of oscillation, and the time period of oscillation is measured. So in the first observation, I observed the time period of oscillation 2.63 seconds, because oscillations are going on. So one oscillation means when one complete left and right movement is completed by the pendulum, then that is the single oscillation. So the time period which is noted, it is 2.63 second. In the second observation, 2.56 second. In the third, 2.42 second. In the fourth, 2.71 second. Means 2.71 second for one complete oscillation. 2.80 second for one complete oscillations. So we have 1, 2, 3, 4, 5 readings. We have 5 readings, means 5 observations, 5 readings, and we are asked to find out most accurate value of time period. Most accurate means we are asked to find out the true value. What is the true value? Means these are my observed values, the observations of my experiment. But there is a true value. Might be possible that during my observation, these values may give some error. It is not the first value is 2.63, maybe some error in this value. 2.56 second, maybe some error. Error due to the instrument may be there. Error due to observation may be there. Similarly, any observation in any value, there may be some error. So how to meet the true value? What is the true time period of oscillation? How to find out that? So first is most accurate value of time period, means our job is to find out the true value. Okay. The second, we will find out the absolute error in this whole experiment. Absolute error in the whole experiment. And then mean absolute error, and finally the fractional error. Fractional error. So this is error, and then finally I will find out the percentage error. Okay. So how to find out the true value? So let me try to find out the first part. Most accurate value of time period means the true value of the time period. So we have these 5 readings, and take the average of these 5 readings, divide them by the 5, then you will get the mean value of the time period. It is 2.62. It is 2.62. So you see 2.62 is not present in our observation, but when we take the mean of all these 5 values, 5 values are there, so divide by 5. If 10 values are there, 10 observations are there, divide by 10. So here we are getting 2.62 second as the true value. So first part is clear. Then in the second part, we will find out absolute error. Absolute error. So absolute error, the formula we know, true value minus observed value. True value, already we get the true value, 2.62 second. So 2.62 second and minus the first observation, 2.63. So true value minus observed value. True value is 2.62 and observed value in the first part of the experiment, 2.63. So the difference of the two minus 0.01 second. Similarly, for the second part, absolute error 2.62, it is my true value, minus the second part of observation, 2.56. So each time what I will do, I will subtract the true value. I will make the difference of the true value minus observed value. So In the second part, I got 0.06 second. Similarly, in the third part, 2.62 is my true value, and 2.42 in the third part, 2.42 is my observed value. So the difference of these two, 0.20. Likewise, in the fourth part, 2.62, it is true value, minus 2.71. You see 2.71, it is observed value. And the difference of the two is minus 0.09 second. Similarly, in the fifth part, true value minus observed value. True value is 2.62 and observed value is 2.80. So difference is minus 0.18 second. So these are called absolute error. Minus 0.01, it is absolute error. 0.06, it is absolute error. 0.20, absolute error. Minus 0.09. So all these values, which are the difference of true value and measured value or observed value, they will give me the absolute error. And I told you absolute error is always taken as positive. So I will not take this minus over here, because when I keep this is in the mode bracket, so it will become positive. So all the values of absolute error, maybe they are coming negative, but we will take them positive. We will consider all the values as positive values. Now, third part, we will find out mean absolute error. We have 5 absolute values: 0.01, 0.06, 0.20, 0.09, 0.18. If we take the mean of all these 5 absolute errors, then we will get mean absolute error. From the definition, it is clear. We will take the mean of all the absolute errors. We have 5 absolute errors, and we will take the mean of 5 absolute errors, and our result is 0.11 second. So this 0.11 second, it is mean absolute error. Now, fourth is fractional error. Fractional error. So what is fractional error? So what I will do, I will take mean absolute error divided by true value. Mean absolute error divided by true value. So mean absolute error is 0.11 second, and true value is 2.62. 2.62. So we will get 0.04. So fractional error means it is the ratio of mean absolute error, which is represented by delta T maximum, and true value. True value is represented by T. So here I have written just true value. So delta T max divided by true value. So that will give me the fractional error. Now the final is how to find out the percentage error. It is very, very simple. So the fractional error, when it is multiplied by 100, it will give the percentage error. So fractional error, we know it is delta T max divided by true value. So when it is multiplied by 100, it will give the percentage error. So I repeat the whole experiment one more time. So we are performing the experiment of simple pendulum, and we have some values of the time period of oscillation of the simple pendulum. So we have 5 observations, 5 values. So all these 5 values, they may not be the true value. They have some errors, because I already told you that in any observation or in any experiment, there are chances of errors. So first we will find out the true value, which is also called the most accurate value of the time period. So that can be find out with the help of mean. So first take the mean of all these values. So you will get the true value, which is 2.62. Then second, absolute error. So each time we will subtract the observed value from the true value each time. So each time we will have an absolute error. Then mean absolute error. Mean absolute error means absolute error, further it is taken as the mean. If we take the mean of absolute error, then we will get the mean absolute error. So we have 5 values of absolute errors. So it is divided by 5. That will give me the mean absolute error. Then fractional error. Fractional error means the mean absolute error when it is divided by the true value, then we will get the fractional error. And percentage error, fractional error when it is multiplied by 100, so it gives me the percentage error. I have one more example. So here we have two resistances. R1 is equal to 100 plus minus 3 ohm. R2 is equal to 200 plus minus 4 ohm. So what is the meaning of 100 plus minus 3 ohm? So it means in our observation, we observed that the resistance R1 that may be greater than 100 or that may be less than 100. It may be 103 and it may be 97 ohm. It may be in R1, it may be 103 ohm when 100 plus 3 is taken, so it is 103 ohm, and when 100 minus 3 is taken, it becomes 97. So there may be the range, means the exact value that may lie between 97 and 103. Similarly, in the R2, in our data, we have 200 plus minus 4. So 200 plus 4 means 204, 204, and 200 minus 4, it is 196. So the range means our true value that will lie in between 196 and 204. So this is called a range of resistance R2, range of resistance R1. So range of resistance R1 is from 97 to 103, and range of resistance R2 is from 196 to 204. So we are given a range of two resistances, which is in ohm. And finally, these two resistances, they are connected in series. Already you must have studied in your previous classes how to connect the two resistance in series. So when end of the first resistance is connected with the second resistance linearly, then it is a series combination. And already you know that in series combination, the current flow is same in both R1 and R2. So current is constant, but potential difference is different. Across R1, we will take V1 as the potential difference, and across R2, we will take V2 as the potential difference. But here we are not interested in any current or voltage. Here we are interested in finding the total resistance or the net resistance when R1 and R2 they are connected in series. So here is the formula, but there is some mistake in the formula, so make it correct. R is equal to R1 plus R2. This is plus. By mistake, it is just taken as equal, so make it correct. This is plus. This is plus. So when we connect the two resistance in series, we will take their sum, R1 plus R2. Now the question arises how to add these two. So simply put the value of R1 here, put the value of R2 here. So now, so the first part of R1 is 100 and first part of the R2 is 200. So these are added, 100 plus minus, same plus minus. First part of the both the resistances, they are taken 100 plus minus 200. And the second part of 2, that is also taken. So plus minus 3 plus minus 4 ohm. So when 100 plus 200, it becomes 300, and plus minus 3 plus plus minus 4, that becomes plus minus 7. So finally, the equivalent resistance of the two is 300 plus minus 7. So that was the question. Now, what is the error limit? Error limit means the range of the resistance. So the range of the resistance, that is 293 to 307. So the true value that may lie between 293 and 307. So this is error limit. means within these two values, the true value may be there. So this is the error limit, or you can call it the range of the resistance, 293 to 307. Now here are some questions for you. The measure of accuracy is absolute error, relative error, percentage error, both B and C. What is the? So both B and C. To measure the accuracy, we will find, so with the help of absolute error, it's not possible to find out the accurate value. So to find the accurate value of any experiment or any observation, we have to find out the relative error, or we have to find out the percentage error. So this is percentage error. Already I told you delta A is equal to delta A mean divided by A mean multiply 100. So this will give us the accurate value. As percentage error increases, accuracy increases. As percentage error increases, so as delta A increases, accuracy decreases. The difference between mean value and measured value, means mean value is a true value. So the difference between the true value and the measured value, already you know, it is absolute error. Absolute error, it is equal to true value minus measured value. So the difference between true value and measured value, it is called absolute error. Now we have already systematic errors. They are already taken in the previous lecture, but still there are some new things which are to be discussed in the systematic error. So error, always it is a difference of measured value and true value, or true value minus measured value. So this is called error. Already we discussed the type of error, systematic error and random error. So let us take and then the least count error. Already these are discussed, but still, because they are present in our next slide, so I will take them. Systematic error, that is due to instrumental error. It is due to imperfection in the experiment, experimental techniques or procedure. Means if we are not following the proper procedure to do the experiment, then definitely we will get the error, and it is the category of the systematic error. In the first part, instrumental error, maybe I told you that if we are taking the ammeter, voltmeter or galvanometer, if their pointer, they are not exactly on the zero in the initially of the experiment, then it means it is the instrumental error. And I already told you that instrumental error, further they can be classified as positive error or negative error. So if the pointer of the ammeter or voltmeter or galvanometer that is above the zero, then it is a positive error, and if the pointer is below the zero, it is a negative error. Personal error means if the observer or the experimental person is not seriously doing the experiment, then due to non-seriousness, the error may be there. If we are not focusing on the apparatus properly, we are not serious in our experiment, we are moving here and there in our lab. So the chances of personal error due to any person may be there. So that is called the personal error. So all these instrumental error, imperfection in the experiment technique or procedure, or personal error, they are the part of systematic error. So this is the explanation of all these errors. Then the least count error, especially this term is used for vernier caliper and screw gauge, which are used in the physics lab to find the dimensions of very small objects, to find the diameter of a wire, or to find the diameter of a cylindrical a road. So these vernier caliper and screw gauge are used. What is the meaning of least count? Least count means the minimum reading which we can read on our scale. The minimum observed reading on the vernier caliper or screw gauge, that is called the least count. The smallest value that can be measured by measuring instrument is called the least count. The least count error is the error associated with the resolution of the instrument. So let me take example. If a vernier caliper has the least count as 0.01 centimeter, means the minimum reading which we can find on the vernier caliper, if it is 0.01 centimeter, sorry, okay, so the least count that will be 0.01 centimeter. Similarly, if we take a spherometer has the least count of 0.001 centimeter, then we will take this as the least count. So even this, what information we are getting from the least count? Least count means error that will be of minimum error that will be present in the vernier caliper is 0.01 centimeter. The minimum error which a vernier can give. Similarly, the minimum error a spherometer can give, it is 0.001 centimeter. So the meaning of least count means the minimum error which a vernier or which a spherometer can give. Reducing the least count error. So how to reduce the error in a vernier caliper or in a spherometer or in a screw gauge? The same, we have to repeat the experiment several times and then we will take the mean value of our values. We will take the mean. So this is the main procedure which is followed to reduce the least count error. Perform the experiment many times, get the many values and then take the mean of all those values. That will reduce the error. So already we discussed, so I will skip this slide. Already all these things, most probable value, mean absolute error, relative error, percentage error, all already they are discussed. Now I have one more question for you, very important questions for the competition. So let me take this statement. The side of the object measured by means of a vernier caliper is 3.52 centimeter. If the least count is 0.01 centimeter, estimate percentage error in the measurement. So first try to understand the statement. We are doing one experiment with vernier caliper, and vernier caliper is used to find out the diameter or the length of a small objects. So here we have a very small object whose side is measured by vernier and it is 3.52 centimeter. And least count of the vernier, it is given 0.01 centimeter. So we have to find out percentage error. We have to find out percentage error because there is a true value of that side, but our measured value is 3.52 and the least count is 0.01. So in that case, what is the percentage error? Okay. So least count, it is represented by delta y. So delta y is equal to 0.01 centimeter. And side is represented by y is equal to 3.52 centimeter. So I just try to erase this positive sign. This is coming here. Okay. So least count is represented by delta y is equal to 0.01 centimeter and side of the object is y is equal to 3.52 centimeter. So what is the first step? To find out the percentage error. Percentage error, that will be the ratio of delta y to y multiply by 100. Percentage error, that will be the ratio of delta y. Delta y is least count. So 0.01, and y is the side of the object. So side of the object 3.52. So 0.01 divided by 3.52 multiply by 100. So it will give me percentage error equal to 0.28%. So percentage error is 0.28%. This is the percentage error in our observation or in our measurement of side by a vernier having least count 0.01 centimeter. This much of error is there. So you see that one more thing, because the least count having two significant figures after decimal, so we will take our answer also in two significant figures. So whatever is the least value of least count, even you can take the side is also having the three significant figures. So the answer that will also be in two significant figures. So if we take percentage error as 0.282, so we will just round off and we will take only 0.28 in two significant figures. Another question, the side of the cube measured to be 20.44 plus minus 0.02 centimeter. Find the percentage change in the measurement. Percentage change in the measurement. So we are given the side of a cube 20.44 plus minus 0.02 centimeter. Find percentage change. So percentage change means we will find out the percentage error only. Percentage error. So the same percentage change is called the percentage error. So same technique, the least count, here you will find the least count. Least count means this part is called the least count. So the least count is delta y is equal to 0.02 centimeter. And y is the actual side of the cube, 20.44 centimeter. So percentage error dy or delta y divided by y multiply 100. So delta y is 0.02 divided by y 20.44 multiplied by 100. So this will give us a percentage error 0.098%. 0.098%. So in this case, because we cannot we can take 0.098, but we will take the more precise value. When we are dealing with such type of questions, then we will take the most precise value. So here 0.098%, that is our precise value. So the percentage change or the percentage error, percentage change is also called percentage error. So 0.098. So let me check. I have only 2 minutes. So just I will end up with this slide and then we will meet in the third lecture. Thank you. So let me take the attendance. We have Ayush, Adarsh, Payal, Suhani, Vansh. Okay, so I have only 1, 2, 3, 4, 5 students. Okay, thank you.
Thank you, sir.
Yes, sir.
Okay.